Good morning, ladies and gentlemen. The date for today is February 8, 2024, and the time is 5:31 a.m. Okay, my topic for this session will be a long video format, and the contents of the topic will be radical equations. It will be solution of problems involving radical equations. Okay, let's proceed. But prior to that, I just want to show you a placer that I assembled, and actually I uploaded this one on my shorts videos also. This is a placer. Okay, you could hardly see this one if it's very bright, but if I will try to lessen the light, you could see this is a placer. Okay, I could do hands-on what you call this assembly of electronic circuits, because I am good with soldering, and I am what they call this I know the components which are used in electronic circuits. Okay, this is for now for this laser. Okay, I will try to open my light again. Okay, my topic for this session will be a practice problem on the solution of the so-called radical equation. Oh, this is just an easy one. So this is a good practice for those who are planning to take up engineering, or if they are planning to take the board exams, because the solution of this might be long enough for the SAT and CAT, but this is a good practice for you guys if you are planning to take the SAT, CAT, or the board exams. Okay, the problem is this one. Find the roots given. We are given the radical equation, the square root of n minus 3 plus the square root of n plus 5 equal to twice the square root of n. The problem is asking for the roots, right? So supposed to be what will be n sub 1 equal to, and what will be n sub 2 equal to. How come I place it there, n sub 1 and n sub 2? Maybe luckily, after the so-called elimination of the radical sign, what will come out will be it's not a quadratic equation. It will just be simply maybe a linear equation. So it might just be only n sub 1 maybe. Okay? Even though this is a radical equation, we are not sure if the resulting roots will be two roots. So the problem is just asking what will be n1 equal to. Okay, let's proceed with the solution. Rewriting the given radical equation, I just rewrite it. Okay? Then to compute for n, we must have to eliminate the radical sign. Okay? We got an enemy here, the radical sign. We must have to eliminate the radical sign to compute for the value of n. And to eliminate the radical sign, the index is actually 2, right? So what must be done for both the left and right is that we must have to square both sides, right? Because the exponent here is 1/2. Because this one here, if we try to change the variation here, it is actually n minus 3 raised to the 1/2. And this is n plus 5 again raised to the 1/2. Same as radical sign. And this is actually n raised to 1/2. Right? So to remove this 2 here on the exponent, okay, we must have to raise all this to the second power. That's why I place it here, square both sides. Okay? If we try to square the first one, these two here cancel with this, right? So it will just be simply n minus 3, right? This is a binomial term on the left hand side, right? So if we try to square this one, it will be the square of the first one, because n minus 3 raised to 1 half, raise that again to the second power, these two here cancel with this. So it will just be simply n minus 3, right? N minus 3. It's a binomial, right? And the middle term will be the product of this one times this one times 2. So it will be twice the first one, the square root of n minus 3 times the square root of n plus 5, which is actually n minus 3 to the 1 half, or n plus 5 to the 1 half. And the last expansion on the left hand side is actually the square of this. Okay? Same as the first one. So these two here cancel with this. It will just be simply n plus 5. Okay? For the right hand side, 2 times n raised to the 1 half quantity square. Product, right? So 2 square will be 4. And n raised to 1 half, we square that again. These two here cancel with this. So it will now just be simply n. Okay? Laws of exponent. Simplifying this one, n plus n is actually 2n. Right? Is it correct? And minus 3 plus 5 is actually plus 2. Okay? We combine n and n, that will be 2n, and the minus 3 plus 5 will be positive 2. Okay? Plus, twice, we could put this one now under one radical sign. It will be the square root of the product of n minus 3 times n plus 5. That's the simplification, right? We put it under same exponent, and this should be equal to 4n. Okay? What will be next? We transpose this to the right. So 4n minus 2n will be 2n. Okay? We transpose this to the right. Okay? Then we rearrange. So this will now be minus 2. We maintain this one on the left, but we rearrange. We put it on the right. So this will now be twice square root of n minus 3 times n plus 5. All the terms has a common factor 2. So we will multiply all the terms by 1 half. So if we try to multiply all the terms by 1 half, these two here cancel with this, cancel with this. So it will now all become unity, right? So it will now be n minus 1. No more 2 here because it cancels with this. The square root of n minus 3 times n plus 5. Okay? Still, we could not compute for the value of n. We still got an enemy here, the radical sign here. So again, we will square both sides again. Right? The square of the left-hand side, we are squaring a binomial, right? Two terms. It will be the square of n. The middle term will be the product of 1 times n times 2, but it should be minus 2n. The last part will be the square of negative 1, which is plus 1, equal to. For the right-hand side, this is actually raised to the 1 half, right? But we will square it again. Okay? Actually, we square this one. So these two here cancel with this. N minus 1 quantity square is this one. So the right hand side now, since we eliminated these two here, what will remain will just be simply the product n minus 3 times n plus 5. So no more radical sign. Am I still on camera? N squared minus 2n plus 1, I just write this one, equal to. We are taking the product of two different binomial, right? So n times n will be n squared. The middle term will be minus 3n plus 5n, that will be plus 2n. The last part will be negative 3 times plus 5, that will be negative 15. Okay? Actually, this n square here cancel with this. We must have to compute for n. We will maintain negative 15 on the right, so we transpose this to the left. So minus 2n, we transpose this to the left, minus 2n. We maintain this one on the right, negative 15. We transpose this plus 1 here to the right, it will be minus 1. Minus 4n equal to negative 16. Again, we will multiply this by negative 1/4. Right? A minus in a minus will now be plus. Okay, and this 4 here cancel with this. So n now will be negative 16 times negative 1/4. Again, a negative times negative will be positive, and a 16 over 4 will be 4. So the value of n is actually equal to 4. Okay, and to check the validity of our answer, we'll just go back to the original radical equation. We'll substitute the value of n to be equal to 4. So the square root of n minus 3 will be the square root of 4 minus 1. Next one will be the square root of 4 plus 5. Is it equal to? The right hand side is twice the square root of n. Sorry for this one. This is it's not minus 1. This should be minus 3. Okay? Should be minus 3. 4 minus 3 will be 1. The square root of 1, it could either be plus or minus 1. We'll just take the plus 1. Right? 4 plus 5 is 9. It's a positive real number. We'll just consider the positive square root. So it will be plus 3. Okay? Is it equal to? Twice the square root of 4. We'll just use the positive sign. Right? So 1 plus 3 is 4, and 2 times 2 is 4, so it is true. So our answer here is actually correct. Okay? So the correct answer will be 4, and that's the solution of this given radical equation. As simple as that one. So for those of you who are planning to take up engineering, or planning to take up SAT or CAT exam or the board exams, this could come out on the board exams. It's not so hard, but if you don't know how to simplify a radical equation, you will not get the answer. Okay, for those of you who are planning to watch my channel is at youtube.com/Prof. David J. De Los Reyes. If you want to share it, please click share. Try to watch also my short videos. I got some electronic, what do you call this, topics over there. You might be interested in it. Okay, good morning from Los Angeles. David J. De Los Reyes.